Picture this. You are standing in a field somewhere in ancient Eurasia, maybe 12,000 years ago, watching a wolf. Not a modern dog, an actual wolf. Large, lean, wary, built by millions of years of natural selection to be exactly what it is. A highly efficient apex predator with no interest in human company, and every reason to maintain a respectful distance from the strange, fire-wielding bipeds it occasionally encounters near the tree line. Now fast forward, same basic animal. Same DNA, more or less, except now it has a pushed-in face that makes breathing a constant struggle. Legs so short it cannot run properly. A back so long its spine develops problems by middle age. Ears so floppy they trap moisture and breed infection. A skull so compressed that its brain physically presses against the inside of its own head. It weighs 6 pounds. It fits in a handbag. It trembles when it hears thunder. It cannot survive a single winter night outdoors without a heated blanket and a sweater your aunt knitted specifically for it. Same animal. Same foundational biology. Transformed, across a few thousand years of human interference, into something that a wolf from 12,000 years ago would not recognize as a relative and honestly might be slightly embarrassed by. This is what humans did to the dog. And the dog, extraordinary as that transformation is not even close to the most dramatic example of what ancient and post-ancient humans did to the animals they decided to bring along for the ride. Because once our species figured out that we could shape other living things to suit our purposes, that selective breeding, intentional management, and the simple act of deciding which animals got to reproduce and which ones didn't could remodel an entire species across generations. We applied that discovery with a thoroughness and a creativity that is, depending on your perspective, either one of the most impressive or one of the most alarming things our species has ever done. So today, the question on the table is this: what animals did humans deform the most? And the answer is going to take us through wolves, wild cattle, jungle fowl, wild boar, and a grass plant that no longer exists in its original form anywhere on Earth. Through the mechanisms of selective breeding, the timelines of domestication, and the specific, sometimes brutal physical transformations that human preference imposed on creatures that had been shaped by natural selection for millions of years before we showed up and decided we knew better. Spoiler, we did not always know better, but we were very confident. Start with dogs, because dogs are where this story begins, and because the transformation they underwent is the template against which every other domestication has to be measured. The domestication of dogs from wolves represents the earliest known instance of humans deliberately shaping another species, with current evidence suggesting the process began somewhere between 15,000 and 40,000 years ago. The range is wide because the genetic and archaeological evidence points in slightly different directions, and researchers are still working out the exact timeline. What is not disputed is the mechanism or the outcome. Ancient humans, whether intentionally or through the initial accident of wolves learning to scavenge near human camps, began a selective relationship with a subset of the wolf population. The wolves that tolerated human proximity without aggression were the ones that got access to food scraps and fire warmth. The ones that were too aggressive or too fearful were driven off or killed. Over generations, the population of wolves associating with human camps skewed increasingly toward individuals with reduced fear responses, reduced aggression toward humans, and increased attentiveness to human social signals. This was not a plan. This was a feedback loop. But once ancient humans recognized that they could influence the outcome by actively selecting for traits they wanted, protective behavior, hunting cooperation, herding assistance, companionship, the process accelerated dramatically. And the physical consequences of selecting for behavioral traits, a phenomenon geneticists now call the domestication syndrome, were extraordinary. Reduced aggression correlates through developmental biology with changes in the neural crest cells that migrate through the developing embryo and influence a wide range of physical characteristics: floppy ears, shorter snouts, smaller teeth, reduced brain size relative to body size. Juvenile facial features retained into adulthood, a phenomenon called neoteny. Piebald coloring patterns, curled tails. None of these physical traits were directly selected for in early domestication. They came along as biological baggage attached to the behavioral traits that were selected, because the developmental pathways are linked in ways that early humans could not have known about and would not have understood even if they had. The result, across thousands of years, was the proto-dog, already physically distinct from its wolf ancestors, already behaviorally transformed in ways that made it useful and appealing to human groups. And then, much later, came the deliberate aesthetic and functional breeding that produced the extraordinary diversity of modern dog forms. The physical range of the domestic dog today, from the Irish Wolfhound to the Chihuahua, from the Greyhound to the Bulldog, represents a degree of within-species morphological variation that has no parallel anywhere in the natural world. No other species on Earth shows anything approaching this range of body size, skull shape, leg proportion, coat type, and overall physical form within a single species boundary. Some of that variation is functionally useful. Greyhounds are fast because humans needed fast dogs. Border Collies have their particular herding intensity because humans selected for herding behavior over centuries. But a significant portion of the physical extremes visible in modern dog breeds are the product of aesthetic preferences that have imposed genuine physiological costs on the animals bearing them. Brachycephalic breeds, dogs with severely flattened faces, including bulldogs, pugs, French bulldogs, and Boston terriers, suffer from a condition called brachycephalic obstructive airway syndrome. The compression of the skull that produces the flat-faced appearance also compresses the airways, the soft palate, and the nasal passages. Many of these animals breathe with audible effort at rest. Many cannot exercise for more than a few minutes without respiratory distress. Many cannot sleep lying down because the airway obstruction worsens in that position. The sounds that owners of these breeds sometimes describe as endearing, the snuffling, the snoring, the constant noisy breathing, are the sounds of an animal working hard just to move air in and out of its lungs. The bulldog, specifically, represents perhaps the most extreme case of human aesthetic preference overriding biological function in the entire history of animal domestication. The modern bulldog's head is so large relative to the birth canal of the female that the vast majority of bulldog puppies are born by cesarean section. The breed cannot reproduce without surgical intervention. A species, or in this case a breed, that cannot reproduce naturally without human medical assistance has been shaped so far from its biological baseline that it has lost one of the most fundamental capacities of any living organism. And humans did this on purpose, through deliberate selective breeding, because they found the physical appearance appealing. Now, move to cattle, because cattle represent a different category of transformation. One driven not by aesthetic preference but by utilitarian demand, and one that reshaped not just the physical form of the animal, but its entire metabolic and reproductive biology. The wild ancestor of domestic cattle is the aurochs, Bos primigenius, an animal so different from modern cattle that standing next to one would remove any casual assumption that they are closely related. Aurochs were enormous. Bulls stood nearly 2 meters at the shoulder. They were aggressive, territorial, and built for the kind of open landscape grazing that required both the physical capacity to cover large distances and the defensive capability to deal with predators that had not yet learned to be afraid of them. Julius Caesar, writing about aurochs in the 1st century BCE when they still existed in European forests, described them as barely smaller than elephants, and noted that even young men who killed them in hunting considered it a significant achievement. Ancient humans domesticated aurochs beginning around 10,000 years ago in the Near East, in what appears to have been an independent process from a separate domestication event in South Asia. Bringing aurochs into a domestication relationship was not a casual undertaking. These were not animals that tolerated human proximity with equanimity. The initial domestication of aurochs almost certainly involved generations of dangerous, difficult management of animals that actively resisted human control, and the process of selecting for reduced aggression and increased tolerance of human handling was slow, costly, and occasionally fatal for the humans attempting it. But the transformation that followed was extraordinary. Modern cattle breeds are, on virtually every physical metric, dramatically reduced versions of their aurochs ancestors. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. They are smaller, in many cases less than half the body mass of a wild aurochs bull. They have reduced horn dimensions, in many breeds approaching 0. Their temperament has been selected toward tractability so thoroughly that animals descended from one of the most dangerous large herbivores in Eurasia now stand placidly in fields while humans approach, handle, and milk them without incident. The dairy transformation, specifically, represents one of the most radical metabolic alterations in domestication history. Wild bovids produce milk for a single purpose: feeding their calves for a limited period after birth. Milk production in wild cattle is calibrated to calf nutritional needs, lasts for the duration of the calf's nursing period, and then ceases. Ancient humans, recognizing the nutritional value of milk, selectively bred cattle for extended and amplified milk production, favoring animals that produced more milk, produced it for longer periods, and continued producing it even when separated from their calves. The result in modern high-production dairy breeds is an animal whose mammary system has been pushed so far beyond its natural parameters that management of that system requires constant veterinary attention. High-production Holstein cows produce quantities of milk so far in excess of what any wild bovid's biology was designed to handle that mastitis, infection of the mammary gland, is one of the most common health problems in dairy herds worldwide. The utter conformation of high-production dairy breeds, large, pendulous, extended, creates mechanical strain and vulnerability to injury that wild cattle never experienced because wild cattle never had udders shaped like that. Humans created the problem by creating the animal, and then hired veterinarians to manage the problem they created. Move next to pigs, because pigs are a case study in a transformation that happened surprisingly fast, and that illustrates how dramatically selective breeding can remodel an animal's physical form in a relatively short number of generations. The wild boar, Sus scrofa, is a formidable animal. Compact, powerful, fast for its size, equipped with tusks that can inflict serious injury, and possessed of a temperament that has earned it considerable respect from hunters across every culture that has encountered it. Domestic pigs, descended from wild boar, were being kept by ancient humans approximately 10,000 years ago, with domestication events occurring independently in multiple regions including the Near East and East Asia. The physical transformation that followed was extensive. Domestic pigs developed shorter legs relative to body size, dramatically increased body fat percentages, reduced tusk development, shortened snouts, and body conformations optimized for rapid weight gain rather than sustained movement. The lean, muscular, long-legged wild boar became, across domestication, the round, heavy, short-legged, fast-growing domestic pig. An animal shaped entirely around the human requirement for maximum caloric yield per unit of feed input. Modern commercial pig breeds take this transformation to extremes that would make their wild ancestors unrecognizable. Some breeds have been selectively developed to produce loin muscles so large and heavy that the animals have difficulty supporting their own weight. Leg weakness and joint problems are common in breeds developed for extreme muscle mass, because the skeletal structure that the genetics specified was designed for an animal that weighed substantially less and moved substantially more. Humans selected for meat yield. The joints and legs came along for the ride, and they have not been managing the experience well. Now, arrive at the animal whose transformation is arguably the most complete and the most consequential of any domestication in human history, and which most people dramatically underestimate in terms of how different it is from what it started as: wheat. Or more precisely, the wild grasses that ancient humans in the Fertile Crescent began cultivating around 10,000 years ago, and that became, through millennia of deliberate and accidental selection, the domesticated wheat varieties that feed a significant portion of humanity today. Wild einkorn wheat. one of the ancestral grasses from which domestic wheat descends, has a seed dispersal mechanism that is elegant, effective, and, from a human agricultural standpoint, catastrophically inconvenient. The seeds are attached to the plant by a structure called the rachis, which, when the seeds are mature, becomes brittle and shatters, dispersing the seeds across the ground. This is exactly what a wild plant should do. Shattering the rachis at maturity disperses seeds away from the parent plant, reduces competition, and maximizes the geographic spread of the next generation. For ancient humans trying to harvest those seeds, a plant that scatters its seeds the moment they are ripe is a nightmare. Every attempt to harvest mature grain is a race against the plant's own dispersal mechanism, and a significant proportion of the grain falls to the ground and is lost before it can be collected. Ancient humans, harvesting wild grain, would have unconsciously and then consciously preferred plants that held their seeds on the stalk longer, plants with a tougher rachis that didn't shatter immediately at maturity. Seeds gathered from these plants were the seeds that got planted. Plants that grew from those seeds were more likely to share the non-shattering characteristic. Over generations, the planted population shifted toward non-shattering varieties. This single change, from shattering to non-shattering rachis, represents a transformation that made domesticated wheat entirely dependent on human intervention for reproduction. A wild grass scatters its own seeds. Domesticated wheat holds its seeds on the stalk, waiting to be harvested. If no human harvests it, those seeds eventually fall, but the timing and distribution are wrong for effective natural propagation. Domesticated wheat without human cultivation does not thrive. It has been shaped through human selection into an organism that needs us the way we need it. A mutual dependency that has persisted for 10,000 years and now covers more of the Earth's surface than any other crop. Beyond the rachis change, domesticated wheat underwent transformation in seed size, seed number per head, plant height, resistance to seed dormancy, and kernel hardness, all of which reflect human selection pressure for characteristics that served agricultural productivity rather than the plant's independent survival interests. The wild grasses that gave rise to wheat were tough, dispersed, seasonally flexible organisms adapted for survival in variable conditions without human assistance. Their descendants, in the form of modern high-yield wheat varieties, are organisms so thoroughly optimized for human agricultural systems that they require specific soil preparation, specific planting timing, irrigation, fertilization, and protection from competition and pest pressure to produce the yields that justify their cultivation. The transformation is so complete that wild einkorn and modern bred wheat, while sharing ancestry, look and behave like entirely different organisms, which, in terms of the characteristics that matter for their respective ecological roles, they effectively are. Chickens deserve a moment here because the transformation from red jungle fowl to modern commercial poultry is a case study in the speed at which selective breeding can produce dramatic physiological change when the selection pressure is extreme enough. Red jungle fowl, the wild ancestor of domestic chickens still found in South and Southeast Asian forests, is a lean, alert, highly mobile bird that produces a small number of eggs per year in a seasonal laying pattern timed to optimal conditions for chick survival. Modern commercial laying hens produce eggs at a rate that has no parallel in any wild bird biology, 300 or more eggs per year from a single bird, maintained across a laying period that extends far beyond anything wild jungle fowl experience. This production rate has been achieved through intensive selective breeding over relatively few generations, and the physiological cost to the birds is significant. The calcium demands of producing eggshell at this rate exceed what the bird's skeleton can sustainably supply, leading to bone density loss over the laying period. The reproductive system of commercial laying hens operates at a level of continuous activation that wild jungle fowl biology never approaches. Commercial meat chickens, broilers, present a different but equally dramatic case. Modern broiler breeds have been selected for growth rate and breast muscle development to such an extent that they reach slaughter weight in approximately 6 weeks, a timeline that would have been unimaginable with the genetics of wild jungle fowl. The breast muscles of modern broilers are so large relative to the bird's skeletal frame that many individuals have difficulty walking by the end of their growth period. Leg weakness, skeletal deformities, and cardiovascular problems are documented welfare concerns in commercial broiler production, direct consequences of selecting for growth rate and muscle mass without proportionally selecting for the skeletal and cardiovascular capacity to support them. Here is the thread that runs through all of this. The thing that connects the bulldog's compressed airway to the broiler's struggling legs, to the dairy cow's strained mammary system, to the domesticated wheat's dependence on human cultivation. Every transformation described here was produced by the same mechanism. Humans decided which individuals reproduced and which ones did not. They made those decisions based on human preferences and human utility requirements. And the animals and plants that resulted from those decisions bear the physical imprint of those preferences in their bodies, in their airways, and their joints, and their metabolisms, and their reproductive systems, in ways that range from the impressive to the troubling. Ancient humans who first began managing wolves, aurochs, boar, and wild grasses did not know what they were setting in motion. They did not have a concept of genetics, of selective pressure, of the multi-generational consequences of consistently favoring certain individuals over others. They were solving immediate problems: food security, hunting assistance, fiber production, companionship, with the tools available to them. The fact that those immediate solutions compounded across thousands of years into the domesticated species we have today, with all of their extraordinary utility and all of their physiological compromises, was not planned. But somewhere along the way, humans did begin to understand, in a practical if not theoretical sense, that they were shaping these animals, that their choices mattered, that the dogs or cattle or pigs they chose to breed from influenced what the next generation looked like and behaved like, and they continued making those choices with increasing deliberateness in directions that prioritized human benefit, sometimes at the expense of the animals doing the changing. The animals that humans deformed the most are, without exception, the ones that were most useful to us, the ones we kept closest, the ones we intervened in most completely. And the irony embedded in all of it is that those same animals, the dogs sleeping on our couches, the cattle in our fields, the wheat in our bread, are also the most successful large animals on Earth by almost every population metric. There are more domestic dogs than wolves, more cattle than aurochs, which are extinct, more domestic pigs than wild boar. Domesticated wheat covers more ground than wild einkorn ever did. They were deformed. They were also, by the brutal measure of biomass and population, extraordinarily successful. Whether that trade-off was worth it is a question the animals themselves cannot answer, but it is absolutely a question worth asking.